We continue Unit 13, Radicals and Rational Exponents, with solving equations with rational exponents. To solve an equation with rational exponents is very similar to solving an equation with square roots, cubics, absolute value, or any of the other ones we've discussed this semester. You have to isolate the term containing the rational exponent. Raise both sides to the reciprocal power, solve for x, and check for extraneous solutions. Remember, extraneous means false answer. Let's look at example 1. I have x to the 4/3 power is equal to 16. Let's box that. Is it by itself on one side of the equal sign? Yes, it is. So this is already isolated. So what we want to do to both sides is raise both sides to the reciprocal power. The reciprocal of 4/3 is 3/4. And I want to raise 16 to the 3/4 power as well. So what I have is the 3's will cancel, the 4's will cancel, and that will just leave me with x is equal to the 4th root of 16 cubed. The 4th root of 16 is 2, and 2 cubed is 8. Now let's check our answer to make sure that it does work. Is 8 to the 4/3 power equal to 16? So we have the cube root of 8 raised to the 4th power. Is that equal to 16? The cube root of 8 is 2, and 2 to the 4th power is 16, and that checks. So x equals 8 is an answer. Let's look at the next problem. The base and the power we're going to box off. If it's not in the box, then that means we need to get rid of it. So 3x to the 1/2 power is not isolated yet. We need to undo 6. So let's subtract 6 from both sides. So I have 3x raised to the 1/2 power is equal to -6. Notice that if I put a box around this, it is isolated. There's nothing being multiplied. There's nothing being added. So multiply both powers by the reciprocal 2/1. So this will reduce and leave just 3x. And on this side, -6 squared is positive 36. Now just solve for x. Divide both sides by 3. So x is equal to 12. Now let's check our solution to see if this works. 3 times 12 raised to the 1/2 power plus 6. I need to see if this is equal to 0. So I have 36 to the 1/2 power plus 6. So the square root of 36 is 6, and 6 plus 6 is not equal to 0. So this is not a solution, and this problem has no solution. Let's look at example 3. X minus 1 to the 3/2 power is equal to 8. Notice that when we box it off, it is isolated and by itself on one side of the equal sign already. So next thing I want to do is multiply both sides, both the powers on both sides by 2/3. So the 2's and the 3's will cancel. And that leaves x minus 1 on the left and the cube root of 8 squared on the right. So x minus 1 is equal to the cube root of 8, which is 2, squared. So x minus 1 is equal to 4, and when we add 1 to both sides, x is equal to 5. Is 5 minus 1 to the 3/2 power equal to 8? So this is 4 to the 3/2 power. 4 to the 3/2 power is the same thing as the square root of 4 cubed. And the square root of 4 to the 3/2 power is the same thing as the square root of 4 cubed. The square root of 4 is 2 cubed, so 2 cubed is equal to 8. So x equals 5 is the answer. Let's look at example 4. Notice this time, when I box the base and the power, it's surrounded by lots of numbers that we need to get rid of. It's not isolated. So the first thing I want to do is isolate by doing PEMDAS backwards. That means I want to get rid of anything added or subtracted first. So let's subtract 1 from both sides. Negative 11 and negative 1 becomes a negative 12. Because we combine like terms, we add and keep the sign. The 1's cancel, and now I'm left with negative 3 times 2x plus 4 raised to the 2/3 power. Let's box off our base and our power again. Our next step is to get rid of anything that's multiplied, so we undo the negative 3 by dividing. So I have 2x plus 4 raised to the 2/3 power is equal to 4. Now if I put a box around it one more time, we can tell that this is isolated, and it is by itself on one side of the equal sign. So the next step is to go ahead and multiply the powers on both sides by 3/2. On the left side, that leaves 2x plus 4. And on the right side, that leaves the square root of 4 cubed. And we don't normally put that square root, so I'm going to leave it off. 2x plus 4 is equal to, the square root of 4 is 2, and we cube it. So 2x plus 4 is equal to 8. To solve for x, subtract 4 from both sides. And we get 2x is equal to 4. So x is equal to 2. Let's check this answer and plug 2 back into our original problem. Negative 3 times 2 times 2 plus 4 raised to the 2/3 power plus 1. I want to see if that's equal to negative 11. So inside the parentheses, PEMDAS says we take care of parentheses first. I get 4 plus 4, which is 8. PEMDAS says next, take care of the exponents. Well, this is negative 3 times the cube root of 8 squared plus 1. The cube root of 8 is 2, and that's squared, and let's add 1 to that. So negative 3 times 4 plus 1. PEMDAS says now take care of any multiplication, so this is negative 12 plus 1, and this is negative 11. And since that's what I wanted, this checks, and x equals 2 is an answer.